Okay, hello everyone, and today we are going to discuss about the leetcode 141 linked list cycle. In this question, it asks us to detect if there is the cycle in the linked list. And we can see in example 1, this is a linked list with cycle, and the attribute is 3.22 and 2.20, 0.2 minus 4, and then minus 4 it points to 2 again. So if there is a pointer in this linked list, it will go on and on without the finish. So that is an example of linked list with cycle. And example 3 is an example of linked list without cycle. We can see in this example that there's only one node in this linked list, and if we have a pointer in this linked list, we cannot go on and on because the next element of the first element here is none. It didn't point to anywhere else, so it will go directly to null, and that is an attribute for the linked list without cycle. And here is a more direct way that we can see the difference between the linked list with or without cycle. And we can see here, linked list without cycle is the this is an example. We can see 1.2, 2.23, 3.24, 4.25, and 5. The next one element of 5 is none. So this is it cannot go on and on without an end. And so this is an linked list without cycle. And on the other hand, we can see here, this is an example of linked list with cycle. And we can see 1.22, 2.23, 3.24, 4.25, and then 5 point back to 2. And if we have a pointer here, we can go on, and it doesn't know where is the end. So that is the main difference between these two. And if we want to detect the cycle, we can use the algorithm called a flowy cycle detection algorithm. And the main point is that there's a slow pointer and also a fast pointer in this algorithm. And we in the beginning we initialize them as the head. We point them to the first element in the linked list. And then each loop we advance our slow pointer by 1 step, and fast pointer we advance it by 2 steps. So because if the linked list without cycle, the fast pointer will point to none eventually, faster than slow pointer because it advances by 2 steps every time. And if there is a cycle in the linked list, we can see the pointer will go on and on without an end. So eventually, in a day, the slow pointer will equals to fast pointer, and that means the cycle exists. So this is an example of the algorithm, the process of the algorithm. We can see in the beginning, the slow pointer and the fast pointer all point to 1, and so the first step, the slow pointer will go to 2, and the fast pointer will go to 3. And the next step, the slow pointer will go to 3, and fast pointer will go to 5. And when the loop go on and on, we can see eventually the slow pointer and the fast pointer, they will encounter at some element in the linked list, and that means the cycle exists. Okay, so to implement this algorithm, first we know that the algorithm works if we want to find the cycle in the linked list, and then now is the time that we need to implement it. And here's how we implement it. Basically, we just translate the natural language into Python, and that's easy enough. So we point slow to the head and fast to the head as well. And while the fast and the next of the fast is not none or is not null, we advance our slow pointer and the fast pointer, and by slow pointer by 1 step and fast pointer by 2 steps. And if at some time slow pointer equals to the fast pointer, it means that they point to the same element, and in that case it means we have already detected a cycle in this linked list. And if that is not the case, the fast pointer or next element of the fast is none, that will be the case of linked list without cycle, and we can directly return false. And so that is the code for this solution, and we can run it to see whether it works well. We can see that this algorithm works well and it achieves the outcome like average. So this is basically everyone use this algorithm to solve this problem. And for this problem, we have the time complexity of like O(n), and the space complexity is basically O1 because we don't initialize additional space in this code. So that is basically the solution to this problem.